Hello, everyone. My name is Jose Betancourt. I am part of SUSE's Technology Partners organization within the Engineering and Innovation Group. Today's presentation is an overview of how SUSE technologies can be used in a rapidly evolving sector of the telecommunications industry, radio area networks, as well as a sampling of some of our collaboration with Intel around the FlexRAN reference software platform. So let me present a little bit of the agenda. First, some context on SUSE's presence in the telecommunications industry today. Next, we introduce the telco product solution continuum, and we quickly focus on the radio access network, or RAN. Once we delve into RAN, we show the three current RAN deployment methodologies and the transition to open protocols and commodity off-the-shelf hardware and software platforms with emphasis on Open RAN. After providing a basic understanding of the benefits of Open RAN, we discuss how to leverage cloud-native technologies and the SUSE value proposition in the form of SUSE ATIP, followed by a what's possible scenario in collaboration with Intel. Last, we showed the next steps, additional sources of information, so you can expand your knowledge base in this interesting telecommunications area of discussion. With that, let's get started. So great, let's talk a bit about telecommunications and SUSE. While we may appear to be new to the telco industry, the reality is that we have over 30 years expertise in building and supporting open source solutions for business critical applications. For over 10 years, we have fine-tuned SUSE Linux Enterprise to support the network function virtualization revolution. 3 out of 3 of the telco manufacturers have SUSE Linux Enterprise as the embedded OS in their virtual network function portfolio. And we provide infrastructure for 3/4 of the top 10 global operators. This makes SUSE a truly experienced network partner. What you're seeing on this slide right now is the telco network breakdown, starting on the left with the smart devices all the way to the cloud. Now, today's conversation, though, focuses primarily on the radio access technology and access edge network portions of the end-to-end network. The access and edge network portion in particular is undergoing a transformation towards software-defined, user-focused infrastructure capable to adapt and grow based on demand. Technologies such as Intel's FlexRAN, which we will discuss and later showcase, show you how you can implement a virtualized, software-defined network functions on commodity hardware, in Intel's case, with Xeon processors and Intel accelerator cards, to provide the necessary scalability in the access and edge network portion. Now, the mobile telecommunications industry is undergoing significant changes as we move to technologies such as 5G. Current and future RAN flexibility and scalability requirements drive new implementation approaches such as virtualized RAN or vRAN and Open RAN. Let's discuss these in more details. To establish a base, we first have the traditional RAN, also known as a DRAN, which is what you see on the left. In a traditional RAN, baseband and radio units are co-located at every cell site. It is usually a solution consisting of proprietary hardware and software from a single vendor. In a virtual RAN or vRAN, we decouple the proprietary hardware from the software by virtualizing network functions or VNFs. It does so by virtualizing technologies such as network functions virtualizations or containers for deployment. The baseband unit function transitions to a virtualized distributed unit centralized unit model, or DU and CU. The DU and CU could still be on the same physical server, but in the form of separate virtual structures. The hardware software decoupling provided by vRAN helps achieve new levels of scalability and can potentially decrease the hardware cost. And it can improve application agility since the applications can be upgraded or swapped with ease. However, the interfaces themselves are still proprietary and usually implemented by a single software provider. Enter OpenRAN from the ORAN Alliance, which takes vRAN to the next level of openness. The ORAN Alliance is working on specifications to open the interfaces between the radio unit and distributed unit, and between the distributed unit and centralized units. It opens the door to multiple providers for the different functions. The combination of virtualized network functions, open interfaces, and commodity hardware provides the telco operators with what I call a great power. That great power is choice. Having said that, with great power comes great responsibility. The stack illustration on the right is a small sample of the options available to telco operators today as they implement vRAN Open RAN solutions. With the advent of vRAN and Open RAN, the IHV, chipset, and infrastructure options should look familiar to those in the IT industry. The RAN ISV stack is just a sample of a growing ecosystem. The same thing for the systems integrators. It's a growing ecosystem. So what can SUSE do for telco providers looking at these type of solutions? First, SUSE has 3 decades worth of relationships with the major IHVs. Second, we collaborate upstream in the adoption of open source code for chipset specific features and or optimizations. And third, we leverage our experience to build a solution stack specific to the telco sector. We're going to look at the challenges or the great responsibility operators face when embracing the new RAN options, as well as what SUSE has done to make life easier for the telcos. With the possibilities of commodity hardware options and VNFs via vRAN and open interfaces via Open RAN, it's easy to figure out that telco operators may want to leverage out cloud native technologies as they implement these new RAN solutions. Having said that, container adoption will not come without its challenges, and telcos will have to address these key areas when adopting a container strategy, such as infrastructure. Standardizing hardware from core to edge will require adoption of commodity off the shelf or an approach based on commodity off the shelf. We have multi-cluster management. With a mature vendor ecosystems comes the challenge of hybrid cloud management for public and private clouds and bare metal deployments at the core as well as at the edge. We have vendor-led Kubernetes decisions. While some of the Kubernetes decisions will be made by the telco operator, other times they can be made by the vendor, meaning multi-vendor management with different Kubernetes distributions that could in turn also require multi-cluster management. Continue with some of the challenges. We're talking about security isolation, the tenant separation to minimize service affecting events. We are talking about lifecycle management, adoption of a more open DevOps nature to support CI/CD, to allow for clear upgrade paths and applications onboarding. And operations, increased operational expertise and open source skills may be required. So, given these challenges, what can SUSE do for telco operators in the RAN space? The answer is the SUSE Adaptive Telco Infrastructure Platform, or ATIP for short. SUSE ATIP consists of the edge stack and the management stack. The edge stack, which is on the right, is the runtime environment for your workloads. Each edge site contains at least one instance of the edge stack. It consists of SUSE Linux Enterprise Micro running on private cloud or bare metal with K3s or RKE2 on top as the Kubernetes layer. Its entire lifecycle, including the initial bootstrap, is managed by the management cluster, which is on the left. The management stack has Rancher Prime at its core, enhanced with a couple of extensions such as bare metal and OS management to give us full stack management, programmatic end-to-end infrastructure management through cluster APIs, and a GitOps module called Fleet that has been added to allow drift-free edge infrastructure management at scale. We also have add-ons for cloud-native security and storage that are available. Let's take a closer look at some of these components. On the operating system side, we have SUSE Linux Enterprise Micro, or SLE Micro for short. SLE Micro is a lightweight, immutable OS well suited for decentralized computing. It has a minimal footprint that helps reduce the potential attack surface. It leverages the enterprise hardened security and compliance components from SUSE Linux Enterprise Server. It supports transactional updates, has a real-time kernel, and it supports components such as XDP and DPDK, to name a few of its capabilities. It can also be managed like a Kubernetes workload through Rancher as part of ATIP. We provide two Kubernetes distributions that we directly support in the form of K3s and RKE2 respectively. They provide topology-aware scheduling, several CNI options such as Multus, Flannel, Cilium, and Calico, as well as proven integration with Juniper CM2. We also have a growing exposure to different accelerator technologies, starting with Intel's device plugins operators. And finally, for complete cloud infrastructure, we have Rancher Prime. Rancher Prime is a new edition of the commercial enterprise offering built on the same source code, Rancher. Rancher is a Kubernetes management tool to deploy and run clusters anywhere and on any provider. It centralizes authentication and role-based access controls. It enables detailed monitoring and alerting for clusters and their resources. It ships logs to external providers and integrates directly with Helm via the application's catalog. And with Fleet, you can automatically deploy and upgrade workloads. With the SUSE ATIP solution, we deliver three key items required for current and future RAN telco deployments. First, we have a telco-grade solution from a performance and security perspective. SLE Micro provides a container-optimized small footprint Linux while supporting all key telco-grade features such as real-time kernel, accelerated data path, DPDK, timing NIC support, etc. Second, we simplify operations at scale by reducing overall complexity. Rancher Prime comes with multi-cluster, programmatical interfaces via GitOps or the Rancher UI, zero-based or zero-touch provisioning, and cloud-native OS management, delivering a unified Kubernetes native management across all the layers. And third, we future-proof installations by providing rolling releases to the different products that make up the stack, solution-level testing, and premium support availability. So, how do we show what's possible in terms of building modern RAN telco solutions? The answer is through proof of concepts, showcasing completeness of vision. In this new vRAN Open RAN era, that requires partnerships such as the one shown in this slide with Dell and Intel. This was a collaboration between SUSE and Dell, demonstrating the deployment of Intel's FlexRAN. Intel defines FlexRAN as a reference implementation for cloud-enabled wireless access across virtual network functions, or VNFs. It shows how to efficiently implement wireless access loads through flexible software architecture. Intel's Xeon scalable processors using Intel's AVX 512 extensions and optimized network functions virtualization, or NFVI, with Intel-specific patches for the Data Plane Development Kit, or DPDK. FlexRAN, as the name implies, is flexible and can be further enhanced through Open RAN which supports operations between different equipment vendors. SUSE and Dell proceeded to then build this foundational infrastructure leveraging Dell's compute infrastructure with XR11 servers, SUSE Linux Enterprise Micro, Rancher K3s, and Rancher Management to control the overall Intel FlexRAN environment. There is a link to a complete Dell SUSE Intel FlexRAN test blog that shows how to install and configure FlexRAN, following the architecture shown on the slide, as well as some of the FlexRAN use cases. So we made it to almost the end of the presentation. As you can imagine, the topic of radio access networks, vRAN, and ORAN, and deployment best practices is broad, and we could spend days or weeks learning about all the different deployment options and how to develop a best set of practices for them. However, I think that we established that as telco operators embrace vRAN and ORAN, that they can count on SUSE to provide the software-defined infrastructure to support their deployments today and tomorrow. We demonstrated the value of the SUSE ATIP solution for telcos, and finally, we provided a small glimpse of what's possible leveraging our partnerships with Intel and Dell, showcasing Intel's FlexRAN solution, the SUSE software-defined stack, and Dell compute infrastructure. To learn more, visit the active links in this slide. I listed links for SUSE ATIP, OpenRAN, Intel's FlexRAN, as well as the Dell SUSE reference architecture blog, detailing the Intel FlexRAN architecture implementation with the SUSE stack. And with that, thank you for your time and have a great rest of your day.